Welcome to The Explainer. Today, we're diving into literally the most epic narrative possible, the ultimate origin story. We're going to trace the insanely complex sequence of cosmic events that actually made our very existence possible. I mean, have you ever wondered how the universe went from this unimaginable, abstract state of intense heat and density to, well, biology, to us? How did the cosmos literally set the stage for you and me? Well, let's uncover exactly how those ancient physical conditions paved the way for life.
Okay, let's dive into this. Here is our chronological roadmap for today's explainer. First, the birth of space. Second, the matter advantage. Third, let there be light. Fourth, forging the elements. And finally, number 5, the ultimate consequence. All right, starting with section 1, the birth of space. To truly grasp where life comes from, I need you to imagine a reality completely devoid of stars, galaxies, planets, space, and even time itself. Now, right off the bat, we've got to correct a massive cosmic misconception. When we talk about the Big Bang, you probably picture a giant explosion, right? Like a massive firework bursting inside a huge, dark, empty room. But actually, scratch that. It's not accurate at all. The Big Bang wasn't a giant explosion into an empty room because there was no outside or pre-existing void for it to expand into. It was the rapid expansion of space itself. The box itself was growing. Literally, space and time were born in this very process. So when did this profound expansion actually begin? 13.8 billion years ago. That immense number really establishes the staggering timescale we're dealing with here. For 13.8 billion years, the universe has been evolving, expanding, and undergoing these highly specific physical changes. We toss around the word billion a lot, but pause and really absorb the weight of that time. We're talking 13.8 billion years of continuous, unbroken physical processes leading directly to this exact moment. So what were those very first moments actually like? Well, the infant universe was unimaginably hot, completely dense, and filled to the brim with fundamental particles. Just a chaotic cosmic soup. But then, a hyper-fast period called cosmic inflation expanded the cosmos enormously. And crucially, it didn't expand perfectly smoothly. It left behind these tiny density variations. These minute wrinkles in the cosmic fabric are absolutely crucial because they acted as the necessary seeds that allowed gravity to later pull matter together and form literally all future galaxies. Moving right along to section 2, the matter advantage. Now that space is expanding, we're transitioning into a critical subatomic era where the universe begins to actually build things. What's really interesting about this slide is the direct cause and effect. Step 1, the universe cools. Just like steam condensing into water as the temperature drops, the extreme, chaotic heat of the very early universe had to settle down. And this cooling was the exact prerequisite needed for step 2. As the temperature dropped, elementary particles called quarks were finally able to bind together to form protons and neutrons. So without this massive cosmic cooldown, matter as we know it simply could not assemble. But there was this massive cosmic battle taking place during all this assembly, matter versus antimatter. Early on, these two opposing forces existed in almost perfectly equal amounts, and obviously when matter and antimatter meet, they instantly annihilate each other. Fortunately for us, there wasn't a perfect balance. Most of it was annihilated, sure, but a tiny, vital excess of matter survived the carnage. Matter, thankfully, had the advantage. And that tiny excess of matter provided the material from which every star, planet, and living thing would eventually form. Really think about that for a second. Every single atom in your body, the device you're watching this explainer on, the earth beneath your feet, all of it exists strictly because of a slight margin of error in a massive subatomic annihilation event billions of years ago. Basically, without this specific subatomic victory of matter, you wouldn't be sitting here today. You exist because of a cosmic rounding error. That brings us to section 3. Let there be light. We've got space, we've got matter, but for a long time the universe was fundamentally opaque, a dense fog. Let's see how the cosmos finally cleared it. Watch how this builds across deep time. Within just minutes of the Big Bang, hydrogen and helium nuclei formed, but it actually took hundreds of thousands of years for things to cool enough for electrons to finally combine with those nuclei, creating the very first true atoms. The moment they locked together, the dense, glowing fog of the universe suddenly cleared. For the very first time, light was able to travel freely across the cosmos. And remarkably, 13.8 billion years later, we can actually still observe that ancient light today. That ancient light has a name, the cosmic microwave background. This brilliantly illustrates how we can literally still see the physical aftermath of this exact moment in the sky today. When astronomers point specialized telescopes at the sky, they see this faint, stretched-out glow blanketing the entire universe. And fun fact, if you've ever seen the static on an old analog television set, a small percentage of that visual fuzz is actually you watching the leftover radiation of the Big Bang. How wild is that?
Now for Section 4, Forging the Elements. So far, the universe only has simple elements, mostly hydrogen and helium. But to get our complex chemical ingredients, we need to shift our scale from subatomic particles to massive celestial bodies.
This sequence reads like the cinematic life cycle of a star. In step 1, over vast stretches of time, gravity slowly gathers that early hydrogen and helium gas into incredibly dense clouds. In step 2, the pressure and heat become so intense that nuclear fusion ignites, and the very first stars are born. Now, step 3 is where the magic happens for us. Deep inside the blazing cores of these giant stars, heavier elements like carbon and oxygen are actively forged. And finally, step 4. When these massive stars reach the end of their lives, they die in violent supernova explosions. These massive detonations were the absolutely necessary delivery system to violently spread these newly forged heavy elements far and wide across space.
And that sets the perfect stage for Section 5, the ultimate consequence. Let's bring this grand 13.8 billion year narrative right to our home planet. The material blasted out by those ancient supernovas didn't just disappear. Those enriched elements formed entirely new generations of stars and planets. Our own sun and the Earth were formed from this recycled element-rich cosmic dust. The crucial point here is that the emergence of life on Earth directly relied on those heavy elements forged in the cores of dead stars. You are, quite literally, made of star stuff. Which brings us to this quote from our source material that perfectly captures this reality. While the Big Bang did not directly create life, it created the universe and the physical conditions that made life possible. This perfectly summarizes the causal relationship we've been tracking today. The Big Bang wasn't a biological event, but it was the ultimate prerequisite. It set up the dominoes of space, matter, chemistry, and physics that eventually cascaded into the complex biology we see all around us. So, let's quickly recap this incredible cosmic story. It started unimaginably hot and dense. Over billions of years, it expanded, cooled, and organized into galaxies, stars, and planets. Out of that complex physical evolution, it created observers, us, human beings who are now capable of looking back and uncovering these incredible mysteries. And all the while, the universe continues its relentless expansion outward. To wrap up, I want to leave you with a final, provocative thought. If the Big Bang gave birth to space, time, matter, and the chemical building blocks of everything we know, is the Big Bang the ultimate cause of life? Or was life simply an extraordinary, almost accidental consequence of billions of years of cosmic evolution? It's a fascinating boundary between physics and biology. What do you think? Thank you so much for joining me on this incredible journey through time and space. Keep asking questions, and I'll see you in the next explainer.